Lead levels. So the individuals studied here are American children, ages 1 through 5, and we have a different set of children, obviously, at different points in time. And for each child, what we record is their blood concentration of lead in microgram per deciliter, so a quantitative variable. The figure represents the results of those various surveys over time, so it is a time plot, though you should notice that the intervals on the horizontal axis represent the successive surveys. They are not necessarily all equally spaced in time. The figure shows specifically the median and the 95th percentile of those blood lead levels. Statistically, the median is the midpoint of the distribution, such that half of the individuals studied have values like that or smaller, and the other half have values like that or larger. So, for instance, for the earliest survey we have here, we can see that the median was roughly 15 microgram per deciliter. That tells us that in this particular survey, half the children had blood lead levels at most 15 microgram per deciliter, so 15 or less. And the other half, the other 50%, had lead levels that were at least 15 microgram per deciliter, so 15 or more. The 95th percentile follows the same principle, but we divide the distribution into the bottom 95% and then the top 5%. So that means that 95% of the children in that earlier survey had blood lead levels of at most roughly 29 microgram per deciliter, and the remaining 5% had blood lead levels of at least 29 microgram per deciliter, so 29 or higher. Other measures like the average and like the maximum can easily be influenced by extreme values. So specifically in the context of a variable like blood lead level, you could end up with one child in your sample that had accidentally an extremely high level of exposure to lead, maybe by eating some paint chips from a wall that was painted with old lead paint. And depending on whether your survey happened to have one of those really rare accidental cases or not, that would give you a completely different picture of the blood lead levels among young children. So using measures like the median and the 95th percentile give us more stable values, especially when we want to do comparisons over time from one survey to the next. So how do we summarize the findings here? Well, we can see that for both the median and the 95th percentile, there is a clear reduction over time of lead levels, and that this reduction is more pronounced in the earlier part of the graph, so for the earlier decades. We also noticed that the gap between the median and the maximum has shrunk over time. So that means there was more substantial difference between a typical child at the median and a child with extremely high exposure at the 95th percentile in those earlier decades. You might want to include in that summary the values or the approximate values that you can read from the graph. So over those roughly 5 decades, blood lead levels have declined on a median basis from roughly 15 microgram per deciliter to right around maybe 1 microgram per deciliter, so a very strong reduction. And likewise, for the 95th percentile, the reduction has been from about 29 microgram per deciliter in the 70s to 2 microgram per deciliter recently.